All right, guys, I'm sorry that I am not there again today. I know this is kind of two classes in a row, but we got lucky last class. Um, Cheer for my gymnasts as we are competing today. Hopefully they make it to states. But I did want to go over, I know you already checked the warm-up and the homework, but I did want to go over number 2 because we haven't really talked about that yet. And we actually aren't really going to talk about it until next class when we do dividing exponents. But just for those of you that maybe were like, oh my gosh, what am I doing? When we distribute our exponent here, we're going to be distributing it to everything inside. So it goes to the numerator and to the denominator. So the rules of multiplication with exponents still applies. It just happens to be in a fraction. Hopefully everything else we did okay with on the warm-up. For the homework, I hope that we did simplify all of our terms that had numbers. So we didn't leave them as 4 to the 8th. We actually multiplied it out. There was one I did want to go over on the back, and it was a scientific notation question. 25 and 26. Remember that we do have to have these written in scientific notation. The answers we got were above 10, so we could not put them in scientific notation, or they weren't in scientific notation. To move them to scientific notation, we took our decimal point and we moved it one time to the left in both examples. Because our exponent was already negative, we were going to be going to the left anyway if we were to be putting our number in standard form. Because of that, our exponent in our answer decreased by 1 based on jumps. So that's why the number went down in actual numerical value. Okay. All right. So go ahead and open up to page 12, please. The notes today are not going to take us long. I promise it's not a 22-minute video. But as a reminder, please pause the video when I ask you to pause the video so that you can do some problems on your own. So hopefully we are open to page 12 because I'm going to go ahead and get started. So continuing with our exponents unit, we're going to be learning about zero exponents and negative exponents today. We are going to be adding these two rules to what we already know in a few minutes. So we're going to be combining zero, negative, and multiplication exponents. Next class, we'll be learning dividing exponents, and I promise you that is the last one. So exponents of zero. Very quickly, and hopefully we actually already know this, but any number to the 0 power or any variable to the 0 power equals 1. And I'm going to prove to you why. So let me add a blank page real quick. And I'm going to blow your minds. Okay, so I'm just going to write some numbers down real quick. Okay. 10 squared is 100. 10 to the first power is 10. 10 to the 0 power is 1. 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 100. I'm going to write the fractions to make it a little more understandable for us. I'm going to write these as decimals to kind of prove to you why this works. If you notice the pattern on the left side, our exponents were going down in numerical value. 2, 1, 0, negative 1, negative 2. On the right side, every single time that we decreased value, we took away a 0, which is why 10 to the 0 power is just 1, because we took away a 0 after the 1. So it's just kind of that visual to help you understand that. Now we're going to be moving into negative exponents, and hopefully this picture kind of continues to help you. Looking at the decimals, we're now taking, before we were taking the 0 away, we're now adding the 0 onto the front. And wow, I'm sure somebody screamed Hazo because Mrs. Hayes goofed up a little bit. but I caught it. So we're adding a 0 here each time that we go down into the negatives. We also can be representing this as a fraction because we know that every decimal is also a fraction. We're going to be working more with fractions, not decimals, in the exponents unit. But hopefully this picture just helps you to understand that 0 power rule, because that was kind of the main purpose of it. Okay, so now talking about negative exponents. Any exponent to a negative, or any base that has a negative exponent, I always say is negative about where he lives. So in this algebraic example, we have a to the negative n. This negative n here, he's negative, he's unhappy, he doesn't want to be here. So we're going to move him out of his home and into the basement. And now he becomes positive. So basically what I'm telling you is that any negative exponent, you are going to move it to the opposite side of the fraction to make it positive. So they are now positive about where they live. In the numerical example we have here, we have 2 to the negative 3. And so we need to bring him down to the basement to make him happy, which is how we get 2 to the positive 3. So we're going to practice that with some examples. First off, number 1, anything to the 0 power is 1. So number 1 is just 1. Number 2. This is where, I don't know if you noticed above, but I was boxing all of the negative exponents. This is where it's going to really, really come in handy. You're only moving terms or variables or letters, variables or numbers that have negative exponents. So looking at number 2, I'm going to put a box around that negative 2 exponent and the negative 3. The variable or number it's attached to moves with it. Did I do anything with the 2, the base 2 here? No, because its exponent is a positive 1. So the 2 stays. The x and the y go. So I have x to the positive squared and y to the positive cubed. The 2 stayed alone because it is a separate part of the multiplication problem you have. And so guys, that is your answer. We made the x and y happy about where it lives by moving it down. Okay. So now in number 3, we're going to go ahead and apply what we already know. We're going to be multiplying our exponent inside. So I'm going to end up with 5 to the negative 3 and x to the negative 3. Hopefully we realize that both of our exponents here are negative because we distributed a negative exponent. So I'm going to box both of those. And I know they're both going to need to move down to make them happy. So I'm going to have 1 over 5 cubed x cubed. So if we now simplify it, we get 1 over 125x cubed. Remember to always simplify your numbers. Okay. Skip number 4. Move to number 5. Number 5 looks a little different. So far I've said we're moving it down to make it happy. But if you remember a little bit, I kind of mentioned it. Earlier I said you have to move it to the opposite side of the fraction to make it happy. So in number 5, is the 8 carrying a negative exponent with it? No, because it has the positive 1 exponent. So the 8's going to stay. It's happy about where he is. Now the m to the negative 3. I'm going to box that negative exponent. He's negative about where he lives, so we need to move him to the other side of the fraction. So we're bringing our m to the negative 3 up, and we are left with 8m cubed. Okay. Let's look at number 6. It looks ugly, but I promise it's really not that bad. So let's keep doing what we're doing. We're going to box the negative exponents, leave the positive exponents and numbers alone that have positive exponents. So in number 6, negative 45, is that an exponent? No, it's a negative number. It is not a negative exponent. The exponent on 45 is 1. So it is a positive exponent. He stays alone. So many of my students try to say it's negative and move it down. You're only looking at the exponents, guys, not the whole numbers or the integers that you have there, the coefficients. Okay? So I'm going to be putting a box around my y to the negative 8 and a box around my z to the negative 5. So I know my y needs to go down. My z needs to go up. Everything else stays where it is. So I have negative 45 x cubed on top. I also have z to the 5th because I had to bring it up to make it happy. And then I had to bring down my y to the 8th to make it happy. And that be it. Okay, so go ahead and please do number 4 on your own, and then we will move on to the back, and we just have a few more problems to do. So pause the video, please. Okay, so hopefully we got into the 6th over 64, because when we distributed our exponents up top, a negative 3 to the positive 4 there is going to give 4 to the negative 3rd power. But then a negative 3 being distributed to the negative 2 exponent makes it a positive 6 exponent. So he stays where he is. Okay. Moving on to page 13. We are going to do number 10 because it just looks so beautiful. All right, so let's do number 10. This problem here really ties in everything we've talked about so far. So we really need to be careful as we're solving this problem. First thing that I need to do is I need to distribute any exponents that I might have. So up top, I'm going to actually write down these steps because it's adding to what we've already learned about with those steps that we did last class. So 1, distribute exponents, and I am going to abbreviate here. Number 2, simplify numbers, meaning 4 squared equals 16. Number 3, combine numbers and like bases. Whoa, I don't know how I just did that. Sorry. Then number 4, move negative exponents to make happy. And then number 5, repeat step 3 if needed. Step 3 being combining the like bases and numbers. Because sometimes when we move things, we're going to have more combining we need to do. So let's keep those 5 steps in mind as we move to number 10. So in number 10, first we need to distribute exponents. So in the denominator of the first fraction, I see my negative 3 needs to be distributed to both numbers inside or variables inside. So I'm going to rewrite my numerator here, and I'm left with x to the negative 3, y to the negative 6, plus 7xy over x to the negative 2, y to the negative 5th. It now tells you to simplify any numbers that you have. I do not have any numbers down here that have an exponent with them, so we can skip number 2. Now it asks me to combine any numbers or like bases. I can't combine my numbers yet, guys, because we are adding fractions here. Our denominators have to be the same. Hopefully that rings a bell. So I actually can skip number 3 as well for this problem. For number 4, move negative exponents to make them happy. So I'm putting my boxes so they stand out to me. I see 4 negative exponents, all of which will be moving up. So my new problem is going to look like negative 16 x cubed y to the 6th plus 7 xy, because that's what we have written. And then we're bringing up the x squared and up the y to the 5th. And now we're on step 5, which is to repeat step 3. So we're combining our like bases. In the first part of the problem, I don't see anything I can combine, so I'm just going to rewrite it. Negative 16x cubed, y to the 6th, plus 7, I see x cubed, because we can put these x's together, and then I see y to the 6th. Are all of my variables and exponents the same on both terms? Yes, so I can do negative 9 x cubed y to the 6th, because negative 16 plus 7 is negative 9. And you are done. Okay, I would like for you to do 7, 8, and 9. I'm going to have you pause the video so that the answers will be up here when you resume. So you're doing this by yourself. You are not working with a partner. And you can look back at previous problems to help you if you need to, but these steps that we wrote above are really going to help you. So 7, 8, and 9, my friends. All right, here are the answers for 7, 8, and 9. The only work that I really showed for these problems is boxing my negative exponents. So in number 7, I boxed the negative 2, the negative 6. That reminded me to bring them down. And that was it. In number 8, I boxed the negative 10 on the x, brought it up. And again, that was it. Then in number 9, I showed my work kind of by distributing that 0. I know anything to the 0 power is just 1, though. And so I just have g to the 4th times 1, and you're left with g to the 4th. So let me zoom this out for you. By the way, we will be doing this next class, so don't worry about that. Don't cross it out, though, please. We will be coming back to it. I just put that there so that I could remind myself not to go over it. Okay, so now what we are going to be doing is we are going to be working on a few different things. I need your full attention so you understand what to do. First, you are going to be correcting your Where's Mr. Phillips project if it applies to you. I've left a sticky note with the sub with all of the names of people who are allowed to correct the project. Only those students are allowed to correct the project. Once you are done correcting that, or if you are not one of the students that need to correct that, you're going to get in groups of 2 to 3. You can work by yourself if you want to, but you're allowed to be in groups of 2 to 3. That does not say 4 or 5, only 2 to 3, okay? You're going to need to get some materials, which I'll talk to you here about in a second, and you're going to work on the activity for the rest of class. If you finish the activity, which I don't anticipate happening, but you will work on the extra practice pages on pages 11 and 14. 11 is from last time, 14 is from this time. The answers are on the bottom. We included them in this book for you this time. And if you finish that, you have to show the sub, and then you may work on homework. Okay, you need to be taking your time on this activity. So let me go over the activity with you. On Google Classroom, there's a post in the stream. It hasn't shown up yet right now because I'm recording early, but there's a post on your screen that includes the actual material you need in order to play the game. What you're going to do is you're going to grab a deck of the cards from the scratch paper desk. You only need one deck per team. You're going to grab a recording sheet from the scratch paper desk as well, and that is one per person. And then what you're going to do is you're just going to flip the cards over one at a time. So if you're going to flip a card over, let's say you get a 4 of hearts. This document right here has all of the problems for each type of card. You'll notice we're only dealing with the red cards today, and that's because we haven't gotten to dividing or to combining every single rule yet. So today you're only focused on red cards. So if I drew the 4 of hearts, my whole group is doing this problem right here, 4x times 9x to the 4th. You solve it by yourself. Then, once everyone in your group is done, you flip over the next card, and you keep doing that, and you keep doing that, until either you are answering every single one of these questions or until the end of class. If you get a black card today, you're just skipping it. It's kind of like a little break. You can high five each other or something like that if you want to. But next class, what we'll be doing is we'll be checking the answers that you have from the ones you complete today, and then we'll be adding in the black cards. And so you'll be going through the deck again next class. So we will be continuing this, meaning do not lose your recording sheet, because then you will have to start over. The teammate that gets the most answers correct next class will get candy. So take your time. You can use your notes to help you if you need to, but you are competing against your group members. If you have questions, you can play this part of the video again, but the sub should be clear on what we're doing. And so this is what you're doing for the rest of class. All right, be good, and I will see you guys next week. Have a wonderful weekend.